Okay, when I evaluate this expression, I'm literally putting replacing the variable with the numbers it tells me. So instead of having an x there, I'm going to replace my x with a -2. I'm going to copy down the parenthesis exactly as is. Then I'll replace the y with a 1. I'll copy down the +2, and then the parenthesis to the third power exactly like it is. Now, once you have this, you're ready to go ahead and do order of operations. So start with parentheses first. 1 + 2 is 3. And then I have -2 times 3 to the third power, bringing everything else down. Exponents next, so 3 to the third power is 27. So that means this becomes, I'll write it over to the side, -2 times 27. Once again, I get that by doing 3 times 3 is 9, times another 3 is 27. That's how you evaluate an exponent. And then I multiply a negative times a positive is a negative, so that is -54. You could multiply that out, or a small number like 2, you could have gotten the answer by doing 27 plus 27. This next one, I'm going to go ahead and switch colors and try it. So I'm going to replace the A with a 2. I'm going to replace the B with a -3. My markers wanting to be very fat today. And then that's a 2 for my exponent, and then plus a 2. Notice I replaced not one A, but both A's with a 2. So if the same variable shows up twice, replace it both times with whatever number they give you. And notice how when I replace the B, I put it in parentheses. Anytime I have two variables that are variable that's being multiplied by another variable or has an exponent or something like that, I'll always put a parenthesis where the variable was. And it's basically like I'm saying I have A times something squared. So I put whatever that something is inside my parenthesis. Now, when you do that, order of operations, exponent first. So -3 times -3, a negative times a negative is a positive, which is 9. And then 2 times 9 is 18. Plus 2 turns out to be 20. So that's your answer you have there. Now, I've encouraged y'all to be using Desmos, and here instead of another calculator, here's why. If I use Desmos instead of another calculator, I could, after I get it substituted, type in my -2, parentheses, and then the 1 plus 2 to the third power. Now, to get your third power, I go over here, and on my keypad, I can do this exponent button here. This A to the B basically just sticks up a little exponent, and the next number you type will be an exponent. Actually, you can type a bunch of numbers in the exponent, but we don't want to do that in this case. And if you needed to get out of the exponent, you can just click the side of it or use your arrow key to get down and get out of the exponent. So that's how you can do it -54. But there's an even better thing you can do with Desmos. You can type in the original equation, a b squared plus a. Sometimes this doesn't work with your variable if your variable is x, but I have ab squared plus a, and it offers you sliders. Sliders are little tasty hamburgers. We should always say yes to sliders. So I'm going to click add the slider for A and add the slider for B. Now, when I add a slider, it gives me this thing, and I can basically change the value of A and B. And you notice as I change the value of A and B, it changes the value of this expression. So what I can do is I can see the numbers that A and B are supposed to equal. A is supposed to be 2, and B is supposed to be -3. I could slide it over to 2 and get it that way. Or a shortcut is I can actually type there and manually type in -3. So now those are my sliders for 2 and -3, and that gives me my value of 20, which is the same thing I had. I encourage you to work these out by hand because they're very likely show up on the calculator inactive section, but knowing how to check them with Desmos will be useful for you. And if they show up on the calculator active section on your exam, you'll be able to do them that way. I want to look at some applications of evaluating really quick too. This first one is one where they give you an equation. All you're going to do there is plug the numbers they give you into the equation. So I would basically keep the 1/3 like is in the original problem. It tells you the base is 12 and the height is 5. So you just plug in and evaluate from there. On this next one, you would just plug in the 4 where the M is. And then you would say, well, 4 minus 5, is that bigger than 0? No, -1 is not bigger than 0, so that is not a solution.